Assalamualaikum and very good afternoon. Today I will be presenting my paper entitled A Web-Based Early Warning Score Calculator and Data Logger for Patients' Vital Signs Monitoring. My name is Rosmina Jaafar from Faculty of Engineering and Built Environment, University Kebangsaan Malaysia. The co-author for this paper is Ms. Nurul Izzati Kamdani from Faculty of Information Science and Technology, UKM. Vital signs monitoring via early warning score, or the EWS, consists of monitoring human vital signs that are of the systolic blood pressure, diastolic blood pressure, heart rate, body temperature, breathing rate, oxygen saturation, and consciousness level. And these consciousness level are including the AVPU scale, which is the alert, voice, pain, or unresponsive categories. These human vital signs can be normally monitored via National Early Warning Score, or the NEWS system, or it can also be monitored via Modified Early Warnings System, the MEWS, or the Pediatric Early Warning Score, PEWS, and last but not least, Early Warning Score of the Obstetric People, EWSO. However, in this paper, I will focus only on the National Early Warning Score, the NEWS system. Okay, this is the traditional vital signs recording where medical doctors normally use paper chart, and they have to fill in the paper chart manually by handwriting and on the paper. And then they have the second version, or an improved version of vital sign score, where they have improved in terms of putting color coded in the vital signs record. And for each of the score, they have to still manually jot down the values of each of the parameter. And the recording of this style actually consists of hard copy records stored in file, and because of recording many times for different patients and over some time, it will become cumbersome and bulky. And another thing is that for recording the vital signs, they use the key for the NEWS score, where they have to fill in the score, whether the score value is 0, 1, 2, or 3, based on the color coded. Okay, at the end, they will have to total up the score in the bottom of the chart. Okay, in other words, the EWS is calculated manually, and this is very unprofessional and difficult or burdening the medical doctors. The guidelines for news point score, as described by the Royal College of Physicians, include a weightage of certain value of a score indicating patient healthy, and a certain number of value that is requiring the student to have higher level of care. And in terms of the vital signs value, we have respiration rate with the specific score of, for example, if the breathing rate is around 12 to 20 breaths per minute, the score will be 0. If the breathing rate is 21 to 24, the score will be plus. If more than 25, meaning that the person is hyperventilating, the score will increase to 3. Same thing goes if the person is breathing too slow, like for example, the breathing rate is 9 to 11 instead of the normal rate range of 12 to 20. Now the score also have a point score of 1. If the person has a breathing rate very low, less than 8 per minute, the score also increase in value 3. So same thing with the oxygen saturation. A score of 0 is for a person having oxygen saturation more than 96%. If less than that, between 94 to 95, the score will increase to 1. If between 92 to 93%, the score will be plus 2. And if the oxygen saturation less than 91%, the score increase to a value of 3. And the rest goes to other parameters, vital signs like the blood pressure, the temperature, and so on. For the AVPU score, A, which is alert, if the patient is alert, the score will be 0. If the patient is having a response, like response to voice, and the patient is complaining pain, the score will be E. Electronic calculators of the EWS. Nowadays, we have quite a number of available EWS system. A famous one is the MET calculator, and this one is actually available online, and a full version license has to be paid, but mostly the MET calculator can be used on free web. This MET calculator is a computerized vital signs record. It allows ease of data handling and retrieval. It provides online medical reference, also provide point of care clinical decision support tools, and allow the doctor to calculate the total score of the EWS, or it can change to the MEWS or other types of, it can be interchangeably. Okay, it also allows analysis of data. However, the disadvantage of using this MET calculator, the back-end data is not easily accessible for users who want to have a full access to the recorded data. Therefore, there is a need to develop a custom-made EWS system, especially for a specific purpose, such as in a research that requires one to monitor and retrieve recorded data over a long time. So therefore, in this paper, we are describing a custom-made EWS system, and this EWS system will have three main objectives. The first one being as a EWS calculator and as a data recorder, which allow to have a full access to the data recorded. The EWS system design can be described by looking at the flow chart of the caretakers or the users. There are two types of users for the system actually, the caretakers and the super admin. So this flowchart is meant for caretakers, where as a start, the user need to log in to the system. If unsuccessful, it will go to end. If successful, the user or the caretaker has to choose which patient, and by choosing the patient, it can display the patient's profile, edit the patient profile, and caretaker can also edit the caretaker profile himself. Once the user display the patient's profile, it can start recording the vital signs, and also they can do the EWS calculator, can view the history of the EWS, can also insert surgery schedules on doctor's appointment. So all of these can be viewed and stored and saved, and the data is tabulated and saved in a server in the cloud. Next, we look at the entity relationship diagram, and this diagram actually shows the relationship between the parameters or the program in the system itself, where caretaker can have access to the caretaker ID, caretaker name, caretaker email, password, caretaker gender, and so on. Okay, and the appointment, the patient detail, surgery detail, and the score of the use itself. Data dictionary and application framework. There are two application framework used. The first one being the Laravel, which is an open source. It is a modular packaging system, and it's easy to access relational databases. Is easy to program, where we can say it produces a syntactic sugar for programmers. And the PHP by admin is used to administer MySQL, where databases are managed nicely, columns in terms of columns, relations, and the indexes and users and permissions. For the system interface, user need to log in, either the support admin or the caretaker. Once they log in into the system, the user can access to the patient registration, can do the vital signs data input, can access the patient history, also record the doctor's appointment and the surgery schedule. Okay, this is the login page for the patient monitoring system, where there is a username. You need to input the username and password. If not registered with the system, one can create a username and password by clicking the create one. Okay, create an account. A new user need to enter the username, email address, the password, and confirm the password, then click sign up. If the user is already registered, the user can straight away click the login here. Okay, this is the result of the system in terms of the main page. Once the user is able to log in into the system, the main page of the caretaker will look like this, whereby the user can see a list of patients. The user can add a new patient. The user can also edit the patient info, edit the patient profile. User can also view the EWS calculator interface, where in the calculator interface, the vital signs can be entered by choosing the range of the vital signs for the systolic blood pressure, diastolic blood pressure, the respiratory rate, the heart rate, the body temperature, and the AVPU score. The user can also see the patient history interface, where it will display the trend graph of each of the vital signs. Like for example, in this case, the systolic blood pressure curve, the respiration rate curve, and so on. The user can also see the doctor's appointment of the patient, can enter the doctor's appointment date, edit the doctor's appointment, and also add new appointment. User can also see the surgery schedule by inserting a surgery schedule or edit the surgery schedule or add a new surgery schedule. The EWS system has been tested. 4 tests was conducted. The first one being testing the EWS calculator, where the process of testing was to test the calculation of the EWS itself. Okay, from that test, the result is correct, so meaning that the test is successful. And then the EWS history, the process of the test was to test the graph data. In the graph display, only 7 letters data will appear on each of the vital signs trend. Okay, the third test was surgery details. View the surgery details, and the result was able to view surgery details. However, the actual result did not appear nicely, so that this part is failed. And for the fourth test, surgery details view, the second attempt of testing the surgery details, able to test, and the surgery details test was passed. Okay, so the plan for future work, in terms of testing functionality, the system EWS system is working well. All parts of the interface is working. It's able to take the data, display data, and download data nicely. So the only part that is required to continue with the work is to do two testing on the software testing on various devices and browsers, such as testing on the Google Chrome, Microsoft Edge, Firefox, and other browsers. The second test that is planned for the system is usability testing, or the user satisfaction test, to rate how the users of the system, how efficient the EWS system for the users to be used. So as a conclusion, the EWS, in this project, we have managed to develop a custom-made digital system of EWS. The system allowed the patient's vital signs to be recorded, calculated, and stored in a cloud storage. Stored data contain useful information for future clinical decision support, and the system user of category super admin can access to the recorded data. These are the main reference that are used in the paper. That's about it. So thank you, and I welcome questions if you have any.